Let's go over the solutions for your decimal to binary converter 4 bits using the descending power method. Let's just review really quick here the descending power method. We care about only 4 bits, so I'm looking at this part over here of my algorithm. And what I do is, per bit, I'm going to evaluate the input and compare with the decimal weight, in this case first with 8, and I do if it's greater or equal than 8. If that's true, you get a 1, and you're going to subtract and pass that result to the next bit. So let's see the solutions that I'm providing to you on Canvas. And I'm going to provide a VI, and if you double click, it's going to open the front panel. And if you go to Window, Show Block Diagram, it's going to show you the solution. So notice here that I have my input, and the first thing that I do is I have the greater or equal that compares with the decimal weight 8. If that is true or false, this is going to dictate what's going to pass out of the select statement over here. If it's true, I apply the subtraction and I pass forward the result of that subtraction. If it's false, I pass the number to the output. And because the result of this is going to give you a 0 or 1, I just connect to my LED so it can show my binary number. Now I repeat exactly the same thing for the remaining of the bits. I just change the respective decimal weight, 4, 2, and 1. And your last one, you don't need to pass this output to anything. And I put LEDs in front of all greaters or equals to show you your answer. So let's run. If I press play and I move, you can see that you get the right answer. This is 4, this is 6, 9, 13, 15, 14. So everything is working as expected. Let's look now for that extra work. Build a binary to hexadecimal and binary to octal. I'm going to provide also the VI. For that, you double click and Window, Show Block Diagram. Different ways of solving this extra work. The way that I did was I created 4 buttons, and the buttons are the ones that are going to tell me my bits configuration. And then I'm converting that boolean to a number using this module. So let's bring the question mark, I'm going to hover on top of that, and here you go. This one is converting your boolean to a number 0 or 1. So where do you find that one? If you right click and you go to boolean, you have the boolean bool to 0 or 1. Then I'm just converting my binary number to decimal, pretty much what we did on Wednesday, multiplying by the respective weight and then summing everything together, and I get the decimal number. Now here, the way that I use to convert to an hexa and octal, if you right click and you go to your string, you have here a palette called number string and conversion. And inside of this number string and conversion, you can convert a number to a decimal string, you can convert a number to hexadecimal, a number to octal. This is probably the easiest way or straightforward to solve this one. So I place this one and place this one to convert respectively to hexa and octal. And that's the module that you see over here. So this is my question mark, and this is the number to octal, and the bottom one is the number to hexa. And I have a string because I have letters for the hexa, so my display is a string. If I run this, you will see here that I will get the respective octal number and hexadecimal number. So all ones, 15, it's F, 17 in octal, 8 is going to be 10 in octal, 8 in hexa, 9, 10. So you got the idea. Again, different ways of solving this. This is probably like the easiest, more elegant way of solving this. If you have a different one, that's also correct. And I hope you guys will spend time understanding what's going on here.